Hello everyone. I'm here to give this presentation on behalf of the author Teng Shi, and since some reason he can't attend this conference. I will present their paper in these 4 parts. The first, to support the users' diverse information access, many commercial platforms offer both search and recommendation services, creating an opportunity for joint modeling of these 2 tasks. Integrating them helps capture user interests more comprehensively and boosts the performance of both services, while numerous works have explored this joint modeling with promising results. A critical limitation remains. A notable trade-off improved performance in one task tends to reduce that of the other. We also analyzed 2 representative methods, GenSAR and Unifying, and their results further confirmed this trade-off between search and recommendation. Going deeper, our analysis revealed the root cause. These 2 tasks rely on completely different types of information. For example, the recommendation model as SARS-REC works better with ID embeddings, while the search model QEM performs stronger when using semantic information. This makes it clear collaborative information from ID embeddings matters more for recommendation, while semantic information is key for search. Recently, the Generative Retrieval framework, which has attracted significant attention, provides us with a potential solution to this problem. Specifically, we balance semantic and collaborative information through multiple identifiers. Furthermore, under this generative framework, we adopt multitask training to enable the model to meet the requirements of both search and recommendation tasks. First, we designed a search recommendation joint identifiers. For each item, we have a semantic embedding derived from a pre-trained model and a collaborative embedding derived from a recommendation model. After that, these 2 embeddings are concatenated and input into the RQVAE. The RQVAE then learns 2 separate identifiers, one for semantics and one for collaboration, which are used to represent items for search and items for recommendation, respectively. Specifically, first, the semantic and collaborative embeddings are concatenated and then passed through 2 shared codebooks. This process enables the model to learn 2 levels of shared codes, which are used to capture shared information between the 2 tasks. Then the residuals obtained from the first 2 levels are split and passed through a semantics-specific codebook and a collaboration-specific codebook, respectively. This process allows the model to learn 2 types of codes, semantic-specific codes and collaboration-specific codes. These codes are used to capture the task-specific information for semantics and collaboration, respectively. After the identifiers are well trained, we design different training tasks to adapt the generative model to both search and recommendation. First, these tasks include 3 key ones. Next, recommendation item prediction, next, search item prediction, and next, query prediction, all aimed at helping the model learn the distinct requirements for search and recommendation tasks. After that, we designed 2 additional tasks, description to ID and ID to description, to enable the model to predict the corresponding text based on the semantic ID, and conversely, to restore the semantic ID from the task. This ensures alignment between semantic ideas and the text. Overall, during the training phase, we train the model using task-specific instructions for different tasks. At the inference stage, we enable the model to generate the next item for search or recommendation, respectively. By concatenating different start tokens. Finally, we compared our approach with existing generative models for search and recommendation. Our model is built on the T5 small backbone, and we designed and identifiers that balances both semantics and collaborative information, while also being adaptable to both search and recommendation tasks. This design achieved a good balance between efficiency and performance. To verify the effectiveness of our approach, we conducted experiments. Specifically, we carried out the experiments on 2 datasets, the commonly used Amazon dataset and a commercial dataset. Additionally, we compared our methods with commonly used methods in 3 categories: recommendation-only methods, search-only methods, and joint search and recommendation methods. From our experiments, we draw 3 key conclusions about the GenSAR. First, it achieves state-of-the-art performance on both search and recommendation tasks. Second, crucially, GenSAR effectively alleviates the long-standing trade-off between the 2 tasks, balancing them well, unlike previous models. Third, our generative retrieval-based joint modeling approach outperforms both traditional and other generative baselines in the field. To conclude, first, background. Modern apps offer both search and recommendation services, creating a need for effective joint modeling. We proposed GenSAR, whose core idea is balancing semantic and collaborative information via generative retrieval. For implementation, it uses joint identifiers, behavior-aware tokens, and a sequence-to-sequence framework. Training relies on multi-text. Finally, experiments show GenSAR's strengths. It alleviates the search and recommendation trade-off and achieves state-of-the-art performance in both tasks. That's all. Thank you. And since I'm not the author, please, if you have any questions, please contact the author. Thank you.